Which of these two molecules, ammonia or dinitrogen gas, has a higher melting point and why? An atomic fission perspective of what happens when matter transitions from a solid to liquid phase, i.e. melt. The solid, crystalline solid here with the atoms or with the molecules in black dots have a small distance between the molecules, therefore have strong interactions. The heat added is used to break the interactions between the molecules. In liquid phase, post-melt, these lengths are longer, so those forces or interactions must be overcome. The solid that has the higher melting point will have the stronger interactions. If the interactions are strong, it will take a lot of heat and have a higher melting point. So we are going to analyze these two, and the one that has the higher melting point will have the stronger intermolecular force. And intermolecular force is often abbreviated just IMF. Okay? So one of the stronger intermolecular forces is ionic. If we have an ionic compound, we would determine that if one of these was ionic and the other one wasn't ionic, we would say immediately, aha, the ionic compound has the stronger intermolecular force, therefore it has the higher melting point. Neither of these are ionic compounds. They both contain only nonmetals. There's not a metal present. So we continue down the list. Hydrogen bonding, dipole-dipole, and the last one has a couple different names. Van der Waal, London dispersion forces. We continue down the list until we get a hit on one, but not on the other, going from strongest to weakest. Hydrogen bonding. For a compound to be able to participate in hydrogen bonding, it has to have a hydrogen present. There has to be, that hydrogen has to be bound to a nitrogen, oxygen, or a fluorine. If the hydrogen's bound to a carbon, no dice. And there has to be a lone pair of electrons present. This dinitrogen here doesn't have hydrogen present, so it cannot participate in hydrogen bonding. This molecule here, ammonia, it has a hydrogen present, check. Its hydrogen is bound to a nitrogen, oxygen, or a fluorine, check. It has a lone pair, check. So because it has checks on all three, it can participate in hydrogen bonding. With hydrogen bonding being present in ammonia, but not present in dinitrogen gas, this is going to have the stronger intermolecular force and therefore have a higher predicting melting point. We don't have to go down the rest of the list because it took the list from strongest to weakest. Thank you.